Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Well, good evening, everyone, and welcome to the event horizon here on Astronomy.FM radio. That means it is Friday night, and this one happens to be April the 13th, 2018. Yes, it is Friday the 13th. You know what that means? Absolutely nothing.
Speak for yourself, Marty. I've had so much grief at work because it's Friday the 13th. It is not funny.
So it's 9 o'clock in the evening. And Universal Time would be, what time is it Universal Time? 2 o'clock in the morning or 1 o'clock in the morning?
It's 1:01 and 26 seconds.
That's right, because we're daylight savings time now. So 1 o'clock in the morning, Saturday morning, April the 14th.
Hey, Redshirt 33, great to see you.
In our chat room, that would be. So, by the way, come on over to our chat room, everybody listening in right now to the live presentation at Astronomy.FM. Just go up to the homepage where it says Radio Chat, click on that, type in a name, forget the password, leave that blank, and then just hit log in, and you'll be here. So, glad to have everybody here. Got Glenn, you and me and Starstorm, and Evil Spock, and Redshirt 3. Say hi, Starstorm.
Hi.
There you go.
I get it in quadrophenia.
And Black Projects just popped in, too.
Yeah.
Glad to have you here. All right. So, Friday the 13th. I saw a little thing that Neil deGrasse Tyson posted. You know how rare Friday the 13th is? It's just as rare as Thursday the 12th.
But it's Saturday the 14th that you got to watch out for.
Same thing, that's right.
Dun, dun, dun.
Yeah, I'm sure most of us remember the TV series Friday the 13th, which was a spin-off of the films. It was good hokum. It was good fun.
Well, sure, I remember that.
You don't remember? Oh my gosh, Marty!
Television series?
It was a TV series. It was called Friday the 13th. It was a spin-off of the movies. It was about the shop and all the cursed items. The series was about recovering all the cursed items and how the shopkeep, the couple who are looking after them, get locked in one night.
Oh, is that called Friday the 13th? I remember that, like this, antique shop or warehouse or something like that, and they have to. Each item is selected that they have to go and recover. Yes, I thought it was called something else though.
Yeah,
No Little Shop of Horrors. Now that was a musical and a half.
There you go. There was two of them, the original and the original was not a what you call it, musical though, I think.
Anyway, and also of course, what's been going on this week? Well, I'm just leafing through the Comet Watch page. Oh yes, by the way, everybody.
Let's mention it right now.
Yes, let's do that.
We'll
Comet
several
Watch on
times.
after the show. We had Michelle Thaller join us. Yes, we got totally and utterly off the subject on quite a few points in the show. Who cares? It's Michelle Thaller. She's brilliant.
So that's coming up right after the Event Horizon tonight. So stick around, everybody. Keep listening in after we're done. All right, well, let's see where we want to go with. Might as well go with what's coming up on Monday, and that is the TESS mission.
Oh, good.
Launches. TESS stands for Transiting Exoplanet something satellite. I can't remember what it is. We'll get into that in a second. Well, anyways, it's actually going to launch on Monday, April the 16th, Eastern Daylight Time. That's my time zone here, at 6:32 in the afternoon. So make sure you tune in to on NASA TV about a half hour before that time. So 6 p.m. Daylight savings time, Eastern Daylight savings time here in North America. And watch that launch on SpaceX. Yeah, all right, now I'll talk about that probe here. I was trying to find the optical information on it. Couldn't really find that much about it. It's like, they kind of just NASA seems to just kind of glance over stuff for the general public without getting enough into detail. So I don't know what the optics are, but I guess there's 4 cameras in it. Each camera like 2,000 by 2,000 pixels, something like that. Each one's like 21 micropixels or something like that. It's covering. This is not like a detailed, like a highly detailed camera that's going to look at or just zoom in on anything particular. It's going to scan large areas of the sky. In fact, it's going to scan areas that are like 24 degrees by 24 degrees. So that's a pretty big chunk. So try to imagine, well, from the horizon straight up, that's 90 degrees. Halfway down is 45 degrees. So basically a quarter of the way from the horizon up the sky, quarter of the way, that squared, that's the size that they're actually going to scan at a time. So they'll be collecting light. It's not as powerful as, what was the other planet finder that was out? Not Herschel. What was it? What was the one that was just Kuiper? No, not Kuiper. What is it? Oh, wow. I've kind of lost it right now. Well, anyways, yeah, Kepler. That's it.
Kepler. See, I told you it was Kepler.
Yep. I thought you said Kuiper.
No, I said Kepler.
Kepler, yes. So definitely much wider area than that. So at the end, so they want to scan a lot of stars at a time. It's basically trying to catch something going in front of a star. So it's going to be really sensitive to light dips in stars.
Okay, so they're saying there's 4 cameras. They will study 200,000 stars over a 2-year period, looking for dips in light levels that indicate planetary transits. I'm actually on the test page at NASA.
Okay, I was there earlier and I got off.
Now they're saying that the lenses, 7 stacked lenses in each camera to bring the light from distant stars into focus on the detectors.
Anything on the diameter of the lenses? That's what
I'm just going through this as quick as I can because I'll put the graphic in they've provided us on the.
Can you put that link in the chat? Because I'm on that, but I can't find that information.
That's the observatory page.
Okay,
for tests. So, this is terrible because
this page never came up
Tess
for me.
Fontana from Eureka. High five. We're terrible, aren't we?
And I've got the YouTube links for NASA, ESA, and SpaceX.
Excellent.
As usual.
They're looking for Earth and super Earth-sized planets.
They always are.
Stars with spectral types ranging from F5 to M5. Ooh, it's computer, wasn't it?
Its ranges from infrared down to blue.
Yeah.
Spectral range, so nothing that far out of visual range.
Okay. So on the science page, I'll just put that into chat.
Okay.
Okay, so on their science page, what they're saying is the test bright stars are in red, Kepler's faint stars are in blue.
I see they got a chart here.
Yeah, so and it gives you an idea. They're looking for detectable planets around 200,000 pre-selected stars. And
obviously close to the Earth.
Reasonably close to the Earth, obviously, yes. And they actually give you an idea of the instantaneous combined field of view for the 4 test cameras in the middle. So you can actually see how it's going to be imaging the sky. Now, the dashed black circle enclosing the epileptic shows the region where the James Webb will be able to observe at any time.
Okay.
So this is actually this is one of the Goddard sites, and of course they're obviously telling us that at some point TESS and the JWST, should it get up in time, will be overlapping in certain areas where they'll be observing.
Yeah, TESS is generally for the initial finding of potential exoplanets. So the way it works is that obviously the star's going to dip down in light, but not very much. I mean, like it's very, very small fractions of a magnitude. The equipment's getting better to do that now. So very slight dimming of, you wouldn't even be able to see it if you looked at it visually. Slight dimming of the starlight itself, and then you have to go back regularly and take another picture, over regular intervals, and see if it does it again. If it does it again, then you've kind of got, a potential pattern. Then you go back again, take more and more pictures, and see if it does it again. And you have to spend quite a bit of time in order to be able to get some kind of confirmation that you are getting regular dimming. Because that's how they discovered multiple planets, because they got a dimming, and then they got a dimming at a different time, and then they got a dimming at a different, spacing, and then a different spacing. So, and then they look for repeat patterns. Okay, the repeat patterns are let's see, the shortest ones will be inner planets, and then the longer repeat patterns will be outer planets.
Now, Black Projects has put into the chat room some information on the Sol instrument on TESS. It's a package of four wide field of view CCD cameras. Each camera features a low noise, low power 16.8 megapixel CCD detector, which was created by MIT Lincoln Laboratory. It has a 24 degree by 24 degree field of view. A 100 millimeter 4-inch effective pupil diameter, a lens assembly with 7 optical elements, and a band pass range of 600 to 100 nanometers. The TESS lenses will have a combined field of view of 24 by 96 degrees and a focal ratio of f1.4. So basically, that is a wickedly fast lens. That's wickedly fast.
It is.
It's going to be faster than my 3.3 f Dob. But then again, this is in space, and the thing is, with cameras like this in space, you don't worry about atmospheric distortion, and you really don't have to worry about doing lucky sampling on your imaging, because you don't need it. There's literally no atmospheric issues, which is the nice thing, which is why we have space telescopes.
This looks like a less expensive mission to me. Not saying cheap, but less expensive, because it's not like one, big lens or mirror. It's got, four separate cameras, slap them in a box, put solar panels on them for power. You usually got to power up the cameras and the radio transmission equipment and stuff like that. And then some kind of guidance system. Don't know what that is without getting into more detail. Looking it up. And then launch it. And it's not real big. Looks like it's only about 6 feet tall, something like that. It's only 2,000 pounds, maybe, tops.
Now, Red Shirt 3 is asking, he wants to know what the mission duration is. From what I understand, it's 2 years.
I remember now. It's only about 700 pounds.
Yeah. So we're talking about a 2-year mission, which should allow us to bring the James Webb into focus.
One big cost: solar panels themselves.
What?
Okay, the main cost being the solar panels themselves.
Oh, wow. Okay. Yeah, camera's pretty cheap.
Cameras are fairly cheap. See, you can get an off-the-shelf CCD for attaching to your telescope for under 500 quid. And we're talking a very good camera. This is the Altair Hypercam. That's a color imaging camera, no filters, filter wheels. And it's got a Sony CMOS chip on it for the CCD. That's only 500 quid.
I doubt this is color, though. Even though it has a range of from blue to infrared, it's got to be a black and white. Got to be a black and white camera, yeah.
Now, Red Shirt 3 does point out you may not have there won't be atmospheric distortion, but you may get some fisheye distortion. That can be handled, obviously, in the software and removed. It will be just like like processing your CCD images here on Earth. You bung them into something like Nebulosity, Registack, or whatever, and then use your flats, you use your dark frames and everything else and lights, and then basically just process the image. So I would assume that any fisheye issues would be taken out fairly quickly in the processing sections. Yeah.
This is a initial finding mission.
Yeah.
So it's not going to be the high detail. It's not going to be that, as far as I know, it's not going to be the confirmation. Basically, it's going to give some leads to when there should be some exoplanets there, what stars would have them, and what period the planets would be going around the stars, and obviously when the planet should be in front of the stars. So you can get better instrumentation focusing on each individual star. And for instance, doing spectroscopic work to potentially detect some atmosphere of one of those planets too.
Now, Optronics does point out that it does depend if it's a wide-angle lens or not. So that again comes into the whole play. Is it the lens itself is going to be crucial as to whether there will be fisheye distortion or not. To be honest, the only time we're going to know about it is when we start getting the images back from tests. And I'm looking forward to this. This is going to be interesting, and I think this is going to become a citizen science project.
I was going to say,
it might be, yeah.
The Galaxy Zoo thing.
Galaxy Zoo. It could also be bionic driven.
I got a feeling it's going to be computerized, yeah.
As I say, it's going to be interesting. So keep your eyes and ears peeled. And you could probably get involved in it and get your name on the papers.
So we'll see what happens when it comes up. So it'll be interesting to see when they start returning data and stuff like that. And if it is even all that interesting, it might just be technical number type of data. So,
well, as I say,
let's see the 24 by 24 degree. I think that is covered by 4 cameras. So each camera would be doing about 12 by 12. So let's see how. It's not really all that wide angle, I think.
But so the interesting thing is when we actually start getting this preliminary data through. And until then, we're not really going to know what's going on.
Okay.
Yeah, citizen science is fun. I totally agree, Redshirt 3. Okay, maybe it puts up my electric bill a little bit, but whatever.
That's right. Not that much.
It's not that much. And of course, the important thing is, we have some cracking good computers at home, and there is more data coming down than the actual project scientists can manage themselves. That's the beauty of citizen science, really, is that there is this enormous ability to number crunch, report, and integrate, and then we can get they can sit down, they can look at it, they can see what's going on, and start writing the papers. I tend to think most of the discoveries in the last 5 or 10 years owe to being discovered because of citizen science. There is just so many projects out there, and there's so many people who are willing to commit to doing it, even if it just means giving it half their cores and their computer. I have a quad-core computer. I'm barely using 1 core on 2 projects, plus the GPU on my video card.
And sometimes it's just as simple as looking at the picture and marking it with a specific marker.
Yeah, that is the Galaxy Zoo. Well pointed out, Starstorm. Thank you.
I looked up a standard 50 millimeter camera lens, and it says it has a field of view of about 40 degrees. So I'd say this is not wide field photography for each of the individual lenses. So let's say it's 1/4 of that. So it'd be like if it correlates to about a 200 millimeter focal length lens to give you about a 10 degree field of view.
What you can always do,
just guesstimating.
What you can always do if you're really keen to find out is put a FOI request into NASA, to the test team, for more information. this difficult thing called freedom of information. Sometimes it can be abused, sometimes it can't be. And if you're really, really interested in finding out what the cameras can do, I'm sure if you contact the project scientists, God, they would only be too happy. Either that, or we're probably going to get shot for this. Send a message to Michelle Thaler and ask her to find out, because I'm sure that part of her job is to communicate information about NASA projects. So I'm sure she would not be unduly annoyed to get messages requesting information about tests.
Well, we'll see what data comes out. Looking forward to it. And be nice if we could actually get somebody from the test mission to talk to us sometime.
Yeah, we can put in. I'm sure if we put in a request, it will be considered.
Yep.
Now, we were talking of comets earlier. Now, I happen to have run across some mentions about a comet that's in our sky at the moment. It is 21P Jacobi-Zinner. Now, it's currently in the pre-dawn sky.
Is it really? Let me look it up.
Now, the thing is, it's also magnitude 18, so you don't need a telescope and a CCD or a DSLR to get it. In fact, I know Dennis Wojcicki of the BAA Comet section was able to capture it with a series of 10 by 120 exposures. It is currently some way from its predicted position, and he was imaging this from his observatory in Tarbotness in Scotland.
That'd be pretty faint, isn't it?
It is pretty faint at the moment. However...
is it 21P, right?
21P.
All right, I pulled up the data on it.
Yeah. Now, the thing is, they don't know what is the reason for the large distance anomaly. But, of course, obviously, as Dennis points out, because I'm actually reading the Comet Watch post on Facebook, this is a question for the MPC to answer. Possibly they don't have enough astrometry during this current apparition for them to update the orbit. However, I'm sure as time goes by and people are submitting astrometry on this comet, the orbit will be refined. And I think this is one of the times I really have to say I miss Brian Marsden. he was brilliant at motivating people to provide the information he needed to sit down with a pencil and paper and work out an orbit. Showers coming up. Okay, I guess you're talking meteor showers, Starstorm.
Yes.
Okay, let me go and see what. I am going to go to my David Levy book of meteor showers.
All right, and I'm going to go to the American Meteor Society Association.
Normally, I would go to the IMO, which I'm a member of. So
American Meteor Society. That's where I got. Let's see. I don't know if the last month was pretty weak on any meteor shower, so let's see if they've actually improved, or there's increased, I should say.
Right, so we're around April the 13th. So we've just missed the Eta Draconids. Their maximum was around March 29th, 31. And that lasted from about March 22 to April 8th. The Delta Draconids is March 28th. They don't have a maximum, which is interesting. And they are from March 28th to April 17th. It's a moderate velocity, about 26.7 kilometers a second. The other one, which is current, is the Tau Draconids. Their maximum was March 31st to April the 2nd. And they last from the March 13th to the 17th. And there was the Kappa Serpentids, which was April the 1st to the 7th, a very modest 45 kilometers a second, followed by Delta Provonids, which was their maximum was April 5th and 6th, then followed by April Virginids, which was April 7th, 8th, and the Virginids, which goes from February the 3rd through to April 15th. Some sources lump all the Virginid radiants into a single meteor shower, but not everybody does. The other one, of course, or the other two in the Virginids class is the Alpha Virginids and Gamma. Now, Alpha has a maximum of between April the 7th and the 18th, and they last from March 10th to May 6th. It's about 5 to 10 per hour, and it's part of the Virginia complex. The gammas are maximum on the 14th and 15th, so that's coming up.
Tomorrow and Sunday.
Yeah, and they last from April the 5th to the 21st. Rates 3 to 4 per hour, and followed by Sigma Leonids, maximum April 16th and 17th, and they last from March 21st to May 13th. Again, it's a slow shower, but it's not the same shower as the February Sigma Leonids.
Mm-hmm.
And, of course, then we've got nothing till the Lyrids in June.
Lyrids. Well, I got a couple listed on this site. The Pie Puppets max out at April 23rd, and that would be in Puppis. And then the Lyrids, April 22nd. Okay, so let's out of curiosity, let's go over to IMO. And they pop up very nicely because they're one of my saved links. That would be the International Meteor Organization. Yep. To be honest, they are well worth joining. You get a publication about twice or three times a year. Mm-hmm. And, of course, you can submit observations, and they have a weekly meteor outlook by Robert Lunsford. Oh, nice. So let's pop up there and see what he's got for... Oh, here we go. So this is going to be for April 7th to the 13th. This is currently what's going on. Okay. So let me just get back to the chat room, and I'll post the link.
Thank you.
Welcome. And I just can't find... Oh, there's my chat room there. I just lost it for a second. Too many tabs up. That's my fault. Okay, so the moon will reach its last quarter phase on April the 8th. It is a whacking... I'll pull up the moon. Waxing. Whacking. It makes a difference. It's at age 27. It's 27 days. Phase angle of 205.0 degrees. And it is razor thin. It's waning. We're heading into new moon, which is great if you're into comets and to deep sky, meteor showers and deep sky and meteor showers. Yep. Yep. Okay, so he's talking about Zeta Cygnids, and that is April the 6th, date of maximum activity. That's the only one he's really talking about, really there. The center of the large athelion radiant is currently located at 14.04 minus 13. This is in southwest Virgo, 3 degrees southwest of the faint star known as Kang. Oh, Star Trek references tonight. Kappa Virginis. Due to the large size of this radiant, athelion activity may also appear from western Libra as well as Virgo. This radiant is best placed near 0200 LST when it lies on the meridian and it's located highest in the sky. Its rate should be about 2 per hour no matter your location, with an entry velocity of about 30 kilometers a second. It's a slow one. Now, through April the 10th, the last of the Zeta Cygnids. So this position is located in central Cygnus, 3 degrees west of the second magnitude star known as Cedar, Gamma Cygni, and its radiant is best placed during the last hour before dawn when it lies highest above the horizon in the dark sky. Rates are expected to be less than 1 per hour no matter your location. Entry velocity of about 40 kilometers a second. It's a medium thing. So, as seen from Midwest and Northern Hemisphere, 45 degrees north, one would expect to see approximately 4 sporadic meteors per hour during the last hour before dawn, if at a rural observing site. Evening rates would be nearer 2. As seen from tropical southern latitudes, morning rates would be nearer 7 per hour, as seen from rural sites, and 3 during the evening hours. Locations between those two extremes would see activity between the listed figures. Morning rates are slightly reduced due to moonlight. So that's from IMO. All right. Just in time for station identification. Yeah. You're listening to the Event Horizon here on Astronomy.FM radio, about halfway through our program. So 9:30 in the evening for us here in the eastern portion of North America. That would be daylight savings time. And that would put it about 1:30 in the morning Universal Time
For us, April the 13th, and Universal Time, April the 14th.
And Red Shirt is now saying, and now a word about station identification. You know what that brings to mind? It's either Wheel of Fortune or Jeopardy in Outback, and now a word from our sponsors. Okay, April constellations. Thank you, Starstorm. Good idea.
What about April constellations?
Well, we have 8 April constellations. So they include popular groups like Hydra the Sea Serpent, Leo the Lion, Ursa Major, Ursa Minor. And so we have Attila the Air Pump, the Chameleon, Crater the Cup, Hydra, Leo Minor, and Sextans. So these are all they are relatively easy to find constellations. Especially Ursa Major, and certainly Ursa Minor. And of course, if you've been out in the mornings, I have actually still seen Orion getting towards the horizon now, but it is still there.
In the evening?
Well, no, I've actually been seeing it first thing in the morning because I've been going out to read my manual rain gauge.
Orion?
I've seen Orion.
In the morning?
And I have also seen Jupiter.
Let me go double check my star chart for Orion in the morning. I know it's in the evening, but I didn't think it was going to be in the morning. But let me double check.
Yeah, please do. 'Cause, as I say, all I know is it is awfully early when I go and check my rain gauge.
I don't show it.
I might save this
In the-
for the other month.
Nope, I don't show it in the morning.
Okay, then maybe I'm wrong.
Maybe you're wrong.
Hey, maybe I'm still recovering from the night before, which is possible.
There you go.
But anyway, the thing is, finding some of these constellations is very, very easy. So what you need is a star wheel, or you learn to constellation hop.
Mm-hmm.
And I'm going to shamelessly plug this. There is still available a Patrick Moore audio tape and CD that takes you through the constellations, usually going from one star to another. And I'll be honest, this is a very good way to get to know the sky, because when you see something different, you'll know if it's genuine or not, or if it's something that's always been there. So if you don't know your constellations and you see something different, you have to really think about it. Am I seeing something new? Is it a novae, supernovae, or is it a comet, or is it a planet? But the thing to keep in mind is, if you can constellation hop, then you know what to expect. And when novae, supernovae do appear, or we get a really bright comet that's on the edge of naked eye, you know exactly where to look. Mm-hmm. So I really, really do recommend learning your way around the sky.
So many stories about the constellations.
Yes, there is. There's some great stories depending on where you live. If you're going down under, you have the Aboriginal constellations and the Great Emu. It's a shout out to all my friends down in Victoria, that area, and Swan Hill. So yeah,
Greeks had their own stories.
Greeks had their own stories. Most indigenous peoples have their own stories about the constellations. Is it science? No. But you know what? It's still fun. And it is a good way
Have a star party.
to have a star party. Have a star party. Tell stories about the constellations.
And the planets.
Hey, what can you do?
Because a lot of the Greek gods were actually named after the planets in Roman mythology.
And in Roman mythology, yeah. So you have Greek planets, you have Roman planets.
Mm-hmm.
Like
But-
just Jupiter.
Same planets, just different names.
Absolutely. In fact, maybe that's a way you can introduce Astronomy 101 is to say, can you tell me the Greek name for this planet? And hold a card up with a planet on it. There's tons of ways you can make star parties fun. I know a lot of people say they're boring. No, they're not, because I find this is a very good way to try somebody else's kit and see if I like the telescope or the camera that they're using.
Are they eyepieces?
Or the eyepieces, yes, if you're a visual observer.
General setup.
Or the general setup, yeah. So going to star parties can be fun, and it is really, really important. I would never say buy a telescope straight away. I always say buy binoculars. Why? Well, if you find you're not interested, you can use the binoculars for other things. Telescopes tend to stand in the corner unless you sell them off at a great loss.
That's right.
And trust me, I've done it.
Yeah, it kind of started out that way. I was the one that started out with binoculars, and a friend of mine started out with the telescope, small telescope, and got a slightly bigger telescope, and then traded in for a slightly bigger scope, and then traded in for a bigger scope, and I stuck with binoculars.
Well, I started off with a one of those 200 times images of the Andromeda Galaxy type refractors.
Okay, yep.
I wasn't interested in deep sky. I was interested in the moon. It was perfectly good for that. It had 2 eyepieces. One was a narrow view, and another one was a wide view eyepiece.
And the accessories, nobody could figure out what they were.
Yeah.
There's a diagonal.
Yeah.
And then there was the Barlow, which is marginal. And then sometimes they had one called an erecting lens, which actually would flip the image right side up, so you could look straight through the telescope and have your images right side up.
And of course, they had those cruddy filters.
Yes.
Never, ever use a solar filter made of glass.
Well, don't use any. You can use a solar filter made out of glass as long as it's the filter that's made to go on front of the telescope, not back in the eyepiece.
But the thing is, I moved on from that refractor to a 4.5-inch Newtonian. It was hand-driven. I got to know that telescope very well. I got used to literally having my arms at really weird angles, so I could follow the moon or a planet. And after that telescope, I still got that telescope. Ironically, it's sitting in my bedroom right now, boxed up. I just need to fix the tripod.
I have my original binoculars.
Then, of course, I got a 10-inch Meade Starfinder, and I really, really wished I had never sold that telescope because it was a great scope.
Dobsonian style telescope, correct?
No, it was a Newtonian.
Oh, was it? Oh, okay.
The early Starfinders were Newts.
Okay.
I'm moving to a Dobsonian, and I've done the whoop over the fact that it's going to be extremely fast. It's going to be f3.3. I'm wondering if my DSR can keep up with it. The other thing is, of course,
I think we should explain some of the technical terms we're throwing out there about these telescopes a little bit.
Yeah, go for it, Monty.
All right, so Newtonian is an optical configuration. Basically has it's a tube with a mirror in the back, small mirror near the front, which shoots the light out sideways, and that's where the eyepiece goes. And you can put that type of telescope on any type of mount. One of the basic mounts goes up and down, right and left, called an altazimuth, and it's also known as a Dobsonian mount. So when we call something a Dobsonian, it's generally a Newtonian on an up-down, right-left mount. The other type of mount would be a equatorial mount, which is goes your scope, same type of scope. It can be the same type of scope, but it's at an angle, and it will allow you to basically follow the stars. You could motorize a equatorial mount and have it follow the stars just by plugging it in and running the motors. The f3.3 that I was talking about, that's the focal ratio. It's the diameter of the mirror, the focal length. That's the distance from the mirror to where it focuses, divided by the diameter of the mirror or lens. Doesn't matter which one it is. So that means, let's say you have a 1 foot diameter mirror, and it's an f3. That would make the focus distance 3 feet away from the mirror. Now, if you had an f15, that means the focus distance would be 15 feet away from the mirror. Each one has their own advantages and disadvantages. The shorter the focal length, generally the wider angle view you get. The longer the focal length, narrower view, but you get generally higher magnifications with the same eyepiece with a longer focal ratio telescope. So you want a fast one, wide angle, collect a lot of light, see a lot of pieces of the sky. Doesn't do so much on resolution, the ability to see detail on things like planets and stuff like that. But you're going to look at all over stuff, right?
Well, the size of the mirror I'm going for is 20 inches. It's 0.5 meter.
Yeah, that's a lot of light.
A lot of light, and of course, if I turn it onto the moon, I'm going to get an awful lot of features. I'll be able to have some fun going for domes, for rills, for mountains, for the Apennines, and generally just really rocking it out.
It's going to bring in a lot of light, but the bigger the mirror, the better the resolution. But sometimes also looking at detail on the moon, actually, if you stop it down a little bit off axis, you might get a little bit better view because you'll be looking through a smaller cone of light. It'll make the thing dimmer, but a smaller cone of light will have less air distortion. You have to
and of course, the other thing is it's going to be connected to a camera. My eyesight being what it is, I have to take my glasses off to use an eyepiece, and that's just a pain to do all the time. So yeah, I'm going to the dark side. We have CCDs and hot and drinking chocolate always on tap, according to our and digestive biscuits. Yes.
So not only will you flood your eye with moonlight with this thing, you will need a moon filter.
Oh
for
yes.
Your scope. So that could go on the eyepiece. Or I should wear sunglasses.
On the eyepiece, it'll probably be for the camera.
Okay.
I am totally and utterly committed to the dark side. I am an imager.
All right.
And of course, if I can use it for going for comets as well. I sat down and worked out with a friend using the mirror size and everything and the focal ratio that I am going to be going at least down to magnitude 18, maybe 19.
With the camera? Is that what you mean?
Camera, yes. Okay.
So that would be obviously going to be driving. You have to have a drive system.
Yep. I'm going for Servocat and Argo Navis. Okay.
How long of an exposure were you talking about to get down to that 18th magnitude or so?
Well, I'm going to be using probably the Altair Hypercam.
Okay.
So we're talking about stacking images, and we're probably looking at about. I don't think we're going to be going more than 2 or 3 seconds, if that.
Okay.
Per image.
Per image. Okay.
So
is that a chilled camera, CCD camera?
It is it's got its own cooling fans and everything.
Cooling fan. I mean, but it has a cooler, right? So it'll be able to come down tens of degrees below the ambient temperature.
Oh yes.
Okay. Which makes the camera more sensitive.
Reading the specs on this camera, it is considering this is a one-shot color camera.
Okay.
No filter wheels, which is nice.
Right.
Nothing to jam up. Or get out of sequence. So basically, you'll be still using your favorite piece of software to stack and integrate. You can use Lucky Imaging, and literally you'll be. So if you were to go for let's say go for Mars or Jupiter, you would probably be getting some really cracking good images. Basically, it's kind of like using a webcam instead of the DSLR. But the DSLR will be getting a lot of use for planets and for the moon anyway. Because I really don't. And
general deep sky stuff too, I think.
Yeah. Oh yeah. There's quite a few nebulae, both emission and other types that you and reflection that you can go for with the DSLR, particularly when you've got a really fast optical system. And of course, a lot of the comets will also are available to the DSLR, which is great. And of course, people say, "Oh well, it's expensive." Yeah, you get what you pay for. And
yeah, definitely.
With a precision instrument like this, literally, if you pay peanuts, you get a really rotten scope. But you pay decently, you get a good piece of kit. And I know I've talked to some of the people who have been using the scopes the scope I'm going to be buying, and they've all been telling me you've got to get a CCD. You've got to get a CCD. Yeah, fine, right, okay, I can do that. And Black Projects tipped me off about the Altair Hypercam, And it was like, wow, this is fascinating. This is good stuff. And the thing is, there is no bundle of software on discs. It's all downloadable from the manufacturer. You get Sharp Cap. You get everything you need to integrate into your favorite program. Now, at the moment, I'm using Nebulosity. I like it. It's great. I'm going to be going up to PixInsight anyway, because there's a lot of stuff I will need later on when I do go into serious deep sky and go for really faint comets. But both programs are really, really excellent. And if you're going to get started, to be honest, spend a little bit of cash, buy a decent program.
Spend a lot of bit of cash if you can. Now, you don't have to spend the top dollars.
No.
So I found out that sometimes the top dollars stuff can be too complicated, has too many features. It's kind of like it would give you the information on how to fly a fighter jet when you really just want to drive a nice car,
Or fly a nice little Cessna.
Yeah.
The thing is, Nebulosity is $95. Comparing it to other programs out there, that for what you get a lot of stuff for that. There is a learning curve, and like all programs, once you start using it on a regular basis, it becomes automatic. You know what you're doing. You flick into this menu here. You stack your flats, you stack your darks, you stack your lights. Then you pull in your main fits files, do a rough stack with that. Then you start bringing in the stacked flats, darks, and lights and everything else. And then you start working the sliders to complete the processing. A lot of people use programs like Registax. Registax is great, particularly if you're using video capture. You capture maybe 10,000 images in a video, and then you can start stacking it all and start chucking out the really bad images.
Which is done automatically.
Which you can do automatically, yeah. And then you end up with probably the best images you've got, and then you bring them in, and you finish your stacking, you integrate everything, and then you can play with your color balance a little bit. I tend to, particularly with the moon, I'm not interested in fake colors. If I'm going to image something, I want the real color that's out there, which means particularly for nebulae, for galaxies, you're really going to be stacking a heck of a lot of files. And this is where you're going to need a large hard drive, because you need at least, I would say, a 1 terabyte drive. And then you're going to, once you've completed your processing, zip all your files up and put them on a backup disk, so you've got them safe. And of course, the other great thing is these days, you can go to YouTube and you can actually get tutorials that will take you literally step by step by step. That's what I did with Nebulosity. I had one screen with the tutorial. I had the program. I pulled off a series of flats and everything from an image I'd taken on my telescope, and now I'm using that. I'm following the tutorial, taking the steps, and seeing how it all integrates, and that eventually I will get to the point where I can just do this on autopilot. Once you start doing it perhaps on a every other night basis, then you get to go into autopilot, and you know what you're doing, and you can do other things whilst you're thinking about it. Then you can just click OK, and the program does the rest of it for you. Now, Redshirt 3's pointed out that ZWO do some great CMOS cameras. Actually, I think one of the ZWO cameras is the same as the Altair Hypercam. Because I was looking at the image and everything and the specs, and it looks pretty much identical.
I had trouble with
500 quid.
I had trouble with Nebulosity not running the camera at the museum's observatory. It wouldn't work. And I can't remember what that camera was. Something a U16. Who makes a U16? Apogee, maybe?
Okay,
it was an Apogee.
CCD.
Yeah, Apogee U16, it would not run that camera. Came across a problem with that. They never mention that. It doesn't say that, it runs all these cameras, blah, 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 but didn't say it wouldn't actually run the U16.
So that's apology, yeah.
Didn't find that out until I actually got the program and tried to use it. Because before that, I was trying to use Maxim DL, which is a very complicated program. That's one of those jet fighter control programs.
Yeah.
It has too many buttons that do too many things. You can't get a step-by-step procedure for it. I mean, the learning curve is too bad. The videos weren't real good for it. So it's like digressing 10 times before getting back around to the original procedure, what you want to do. It's just too much of a learning curve, and even a lot of astrophotographers found. Regular astrophotographers said the same thing, just the learning curve is too big. Now, if you want to do a lot of custom work, it's great because it has all the tabs and sub-tabs that you need to do all that stuff, but it's kind of hard to just take some basic images with that and figure out what they're talking about.
There you go. There's the link for the Altair Hypercam.
Okay.
It's the IMX 183C. It's a color camera. Mm-hmm. It's got a CMOS chip in the heart of it. And like I say, it's only £549. This is pound sterling. And that includes VAT or sales tax.
I'm still working on a DSLR.
Yeah, so it's got a 20 megapixel Sony IMX 183 sensor.
Now the scope
glow reduction, high sensitivity for extremely smooth detailed images. It has backside illuminated BSI sensors, low read noise. Version 2 has a temperature sensor, region of interest for cropped higher speed solar, lunar, and planetary imaging, and a 4K mode.
Now the scope you want to get, the mount you want to get for it is a Dobsonian mount. Is that correct?
This is a Dobsonian, but it's going to have Argo Navis, and it's going to have ServoCat. Why ServoCat? Because I've got rotation to deal with on a Dob.
Right. So what a Dobsonian can be motorized, but the motors have to be basically, if you want to use it for a camera, you have to have the motors computerized. So you can just get standard motors that'll push a button, it moves it up and down, and a standard motor that moves it right and left. For if you want to find something that way, not too bad. Just push the buttons, move it around. It does it with motors instead of grabbing it. If you want to track something in the sky, you have to have both motors running at the same time. So when something's rising out of the east, the telescope has to go up a little and over a little, up a little and over a little. Now, it can't do that in square steps. It's got to do it synced in smoothly so you get a nice arcing motion through the sky. Now, when you hook up a Dobsonian telescope to an L-Tasmuth mount and you look through the eyepiece, if you were to watch it for an object that was rising in the east and setting towards the west, you would see it basically on one side when it's rising, straight up and down on the meridian, and then it would go over to its other side in the eyepiece view as it's setting. Not good to have something turning while you're taking a photograph of it. So you have to get something called a derotator, which goes on where the eyepiece goes, where the camera goes, and it basically moves the camera in an opposite arc, or basically opposite spin, so that you always keep the top of the object to the top, and no matter if it's rising or on the meridian or setting. So you have to add that to it. Now, a German equatorial mount or any equatorial mount does not need that. As it goes, it arcs across the sky. It always keeps its orientation for your camera or your eyepiece.
I think the great thing, Marty, is going to be that I've still got my C10 Newtonian that's going to. Mm-hmm. So if I want, I can task the Newtonian to be perhaps imaging a comet or a nebula or a planet, and I can be using the second camera I can have on the Dobsonian, and I can be doing the other target I had in mind for that night.
Yep.
I haven't got to worry about. The only thing I've got to worry about is how much space do I have on my hard drive. Mm-hmm. But like I say, if you've got an external hard drive, you can just have it so that you go straight in there. It saves into 2 specific folders, and then you just. I would recommend a third drive, just to be backups, zipped backups of all the files you've used for processing, because you never know when you want to play with them again.
Yep. Speaking of things to look at, there happens to be a nova in the constellation of Sagittarius right now.
Yeah.
I've got, did I put that link into a chat room? Let me put the link into our chat room. Not too bad as far as brightness. It's about 11th magnitude, so kind of dim. Any 6-inch scope or so would be able to pick it up, no problem. So let me put that into our chat room. This is from the American Association of, wait, that's the wrong link. Where am I at here? I did that copyright. Let's try this again. American Association of Variable Star Observers, right on their homepage are alert notices. And it was just from a couple days ago. So a good project to take pictures of.
Okay, now I have been reminded that we have information on this week's planetary roundup. So, Mercury remains hidden in the glow of the sunrise. Venus at magnitude minus 3.9 shines brightly in the west in twilight. It sets a little after night becomes complete. In a telescope look early, it's a tiny disk, 11 arc seconds wide and slightly gibbous. The sun is lighting 92% of its width. As the night comes on, the Pleiades glitter delicately above it as they move closer to it every evening. Mars and Saturn are in Sagittarius, up after about 1 a.m., daylight saving time. By the beginning of dawn, there are 2 bright points in the south-southeast, above the fainter Sagittarius teapot. Mars, slightly brighter, is on the left. Their separation widens from 6 degrees on the morning of April the 14th to about 10 degrees by the 21st. Mars is brightening on its way to an unusually close opposition in late July. It's 10 arc seconds wide now, and magnitude 0.0 compared to Saturn's plus 0.5.
Wow.
Color difference is obvious.
Usually they're the opposite. Usually Saturn is much brighter than Mars.
Oh, yeah. Jupiter, magnitude minus 2.5 in Libra, rises shortly after dark and shines as the brightest point in the late night sky. It's now 3 weeks from its May 8th opposition, so it appears as about as bright and as big, about 44 arc seconds wide it's going to get this year. It's highest in the south, presenting the sharpest views in a telescope around 2 a.m. daylight savings time. Uranus is hidden in conjunction with the sun, and Neptune is deep in the sky glow of dawn. So we'll put the link into chat.
Yep, Neptune is early in the morning. Actually, let's see. Yesterday, Neptune was only 1.9 degrees north of the moon. Well, it's been a bit of a thin crescent moon.
Yeah, so when I've been going out to do my rain gauge, I normally go out around 10 to 6 in the morning. So if I walk out into the garden proper up to where the actual main weather station is and look, I will be able to see the crescent moon, and I can see Jupiter. Obviously, the sun is beginning to come up. The sky is brightening. So, of course, Jupiter's getting to be fairly dim. Good night, Richard 3. Thanks for coming. Great to see you, mate. So, as I say, knowing your constellations means you'll know where the planets are. And that is a much quicker and easier way sometimes of finding stuff.
Got a occultation of the moon and a bright star coming up on April 19th. Alpha Taurus. What's Alpha Taurus? Which one is it, Nick?
Alpha Taurus?
Alpha Taurus. Yeah, yes, what's the name of the star?
Oh, God. Now you put me on the spot. I haven't got my star charts.
Well, like you said, you got to learn those constellations, and you can learn those star names. It is Aldebaran. So the moon's actually going to go in front, first magnitude Aldebaran, April the 19th, but only visible from northern Canada and northern Greenland.
Oh, well.
Also on the same, it's also going to go across a couple other stars in Taurus to the same night, but it'll only be visible from Easter Island, so that'd be kind of nice. That's a fourth magnitude.
That would be a great place to take a telescope.
Yeah, that'd be fourth magnitude star, though. So that's just kind of, but it would be a great spot to go do a little observing.
Well, as I say, I think one of the things I would love to do in my life before I die is go down to the south, see the southern skies, see the emu.
It is nice.
It would be nice, yes, and actually get to hang out with some of my astronomer friends down there.
South is nice.
South is always nice.
Hey, Nick, why don't you call the ship?
Captain Savick, this is the awaiting 3 to beam up. I think we're about ready to come home. We've got all the geological samples we're going to get today.
Sounds good. Don't forget, we've got more programming coming up after the Event Horizon, especially Comet Watch and some other great programming too. So definitely want to stick around tonight for more listening. All right, time for us to head out.
Good night, everyone.
Good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM. There I was, doing my thing.